So the paper we are discussing is from the paper from Northwestern province, I believe, and year 2018, grade 13, second term paper. So for a change, we are starting in the descending order this time. And the first question is from the 50th one. The pressure difference between a horizontal flow tube of radius A and length L, delta P. What is the correct expression that gives the mean velocity of the steady streamlined flow of a fluid of viscosity eta in that tube? Okay, so pressure difference, length is given, radius is given, and that gives the mean velocity is what we have to find out. And viscosity is also given. People who have learned this lesson will know this equation Q equals pi delta P a to the power 4 over 8 eta L. This is called Poiseuille's equation. All right. And Q is the volume flow rate. But the question is about mean velocity. So instead of volume flow rate, you can put pi r squared V, the volume flow rate equal to pi delta P a to the power 4. Actually, it should be a squared because the radius is given as a over 8 eta L. We know even from mechanics, we know volume flow rate is AV. Instead of A, I have put pi a squared and then this. And pi will get cancelled off. And a square and a to the power 4 here. So instead of this, you can put a to the power 2. Therefore, final answer for V will be what? According to this, final answer will V is equal to a square delta P, a square delta P over 8 eta L. The answer for that is first. This is how you do it. Easy. Next one. The speed of transverse progressive wave propagating in steel wire of density 8,000 kilogram per meter cube is 50 meters per second. What will be the stress in the wire? Right now, stress, I don't know how many of you are aware of that. Stress is given by force over area. Force over area. All right. And we know now speed of transverse wave in the wire that is given by V equals square root of T over M. T is tension. So in this case, it's going to be tension over area. And that is equal to square root of, remember now, instead of T, you can put force over M. M is called mass per unit length. And that is also equal to A rho. Hope you can remember that. A rho. Now, simple M is called mass per unit length. So it's mass divided by length. And when you divide mass by length, it is, instead of mass, you can put volume. Volume is area into length into area and length is volume into density over length is L. And that is equal to A rho. A rho. So instead of F over A, you can say it's stress. Instead of F over A, you can say it's stress over rho. So V is actually equal to V is equal to stress over density. Stress over density. So for V, you can put 500 here equal to square root of stress over density is 8,000. So either side you can square it. Square it. Square is equal. When you square it, you'll get 25 into 10 to the power 4 here equal to sigma over 8,000. Then the final answer is going to be 8,000. When you get multiplied, it will be 200 into 10 to the power 3. I'm going, yeah, that will give you 25 into 8 is 200. So 200,000 into 10 to the power 4, and that is our stress. And finally, stress is going to be equal to 2 into 10 to the power 9, isn't it? Yeah, 2 into 10 to the power 9 Newton meter minus 2. That is stress. That is the value for stress. So 49, first answer. And then moving on to the next one, 48. The temperature of air inside the closed chamber of volume 1 meter cube is at 30 degrees Celsius and its relative humidity is 60%. Reducing the temperature to 20%, the excess moisture is removed by condensation. If the temperature again increases to 30 degrees Celsius, then what will be the new humidity in the chamber? Saturated vapor densities at 30 and 20 are 30 and 17.4 this. Okay, interesting. 40 question number 48, right? The temperature of air inside a closed chamber of volume 1 meter cube is at 30 degrees Celsius and the relative humidity is 60. So first of all, at 30 degrees Celsius, all right, at 30 degrees Celsius, 1 meter cube volume, okay, 1 meter cube volume, and relative humidity is 60. So there we have to find out what is the mass of water vapor here. So instead of for mass of water vapor, I'll take it as M initially. Then what do? We know relative humidity is equal to absolute humidity divided by absolute humidity at that temperature of absolute humidity of saturated vapor at that temperature into 100. Right? So relative humidity is given to us as 60, isn't it? Yeah, 60 equal to, for absolute humidity, I can put mass of water vapor divided by volume. Volume is 1 meter cube, luckily. Over at 30 degrees Celsius, guys, they have given us the absolute humidity here. 30 into 10 to the power minus 6 into 100 here. So if you simplify this, you will be getting M equal. Now see this 100 and 600, if you simplify, this 100 goes the other side, this becomes 0.6. 0.6 into 30 into 10 to the power minus 6 is actually 18 into 10 to the power minus 6. Okay, meter cube. Sorry, kilogram. Kilogram. So this is the mass of water vapor we have here. Then what are they doing? Reducing the temperature 20 degrees Celsius. Okay, now they are cooling down the system. Once they cool down the system, what's going to happen? The temperature is going to reduce to 20 degrees Celsius. The volume didn't change. Okay, closed chamber, so they are not changing the volume of the chamber. It's 1 meter cube. Now, what will happen here? Tell you. At 20 degrees Celsius, the maximum amount of water vapor the chamber can have is this much, 17.4 into 10 to the power minus 6. But here it has 18 into 10 to the power minus 6. So what happens is, volume is 1 meter cube. 17.4 into 10 to the power minus 6 kilogram per meter cube. So volume is 1 meter cube here. It will retain 17.4 into 10 to the power minus 6 kilograms per 1 meter cube, and the remaining will precipitate like this as dew. Tell me the mass of dew. How much dew will be formed, people? Can I get a quick response? How much dew will be formed here? How much dew will be formed here?
0.6 into 10 to the power minus 6.
Yeah, good. 0.6 into 10 to the power minus 6. 0.6 into 10 to the power minus 6 kilogram of dew will be formed, and that's not the question. That's not the question, Arida. Yeah, fine. In case if they had asked, this should be the answer. Now what are they doing? If the temperature again increase to 30 degrees Celsius, now the temperature is again increased to 30 degrees Celsius, right? Now what's going to happen? Now we have water vapor, mass of water vapor now, that is equal to just 17.4 into 10 to the power minus 6 kilograms. And remember, the absolute humidity of saturated vapor at this temperature is given to us, that is 30 into 10 to the power minus 6. 30 into 10 to the power minus 6 kilogram per meter cube. Right, now they're asking what is the RH of this system. What is the RH of this system? Right, how do you find it? Go back to the same equation. Here you can say RH is equal to absolute humidity of the air you have inside that divided by absolute humidity of saturated vapor at that temperature into 100. Absolute humidity now inside this is mass of water vapor is 17.4 into 10 to the power minus 6 over 1 meter cube. Kilogram over 1 meter cube. Right? Okay, I'll not put the units, 1. And divided by, at 30 degrees Celsius, the saturated vapor pressure is 30 into 10 to the power minus 6. And you multiply that by 100. Therefore, these 10 to the power minus 6, 10 to the power minus 6 will get cancelled off. I'm getting 30. No, this is 30. Sorry, I forgot a 0. 30 should be here. 30. Should be 30. Sorry, I put 3 in by mistake only. 30. So people, I'm getting an answer like this. This 30, I can simplify one of the zeros of this 100. So 174 by 3, isn't it? I'm getting that as the answer. 174 by 3 percentage. It's there in the answer, no? Okay. First is the first answer. Can someone check the scheme, please? You didn't. Okay. I didn't send you any photos right up now. I can't change the. It's in full screen mode, so if I change it, it'll be a mess. It's the first one, no? Is it? Yeah. Okay. Okay. Right. Thank you. So this is how you do it, people. All right. I will be continue. I'll be continuing the explanations. If you have anything, you can stop me. Na? You can drop a text in the chat, or you can unmute and speak. No problem, because we need to finish 50 questions, so we need to continue with the pace. Right. Let's go to 47th one now. The surface area of bottom of legs of an animal is 0.005 meters square. Okay, and the legs have good thermal contact with ice at minus 10 degrees Celsius. Now, is this the area of all the legs? Legs, no? Okay, minus 10. The blood vessels in the leg are placed 2 millimeter above the ice. The temperature of the blood in these blood vessels is at steady value of 35 degrees Celsius. The thermal conductivity of the leg is 0.006 watt per meter per Kelvin. Now these things should be wrong, should be corrected. No, capital W, capital K. All right, when you write, careful. The ratio of absorbing heat by ice through the legs is, now this is very straightforward, I think. The only concern is, what did you put? Did you take this as a total volume, people? The surface area of bottom of legs of an animal. Since it's in plural, let's take this as the total area then. 0.005 meters squared kiyanne it's like, okay, it's big. Total, yeah, this should be total. Yeah. So we know the equation. What is it? dq by dt, that is equal to k a. What they're asking. K is given. What is k? K value was given. 0.006 into area 0.005 into change in temperature 35 minus 10 over the thickness 2 millimeter, that is 2 into 10 to the power minus 3. 2 into 10 to minus 3. Right. So how would I simplify? I can take this as 6 into 10 to the power minus 3. Therefore, I can cancel out this and put a 3 here. 3, and then is the final answer paper. What? 3 into 0.005 into 45. 45 here. 45 into 3 into 0. Okay. 45 into 3 is 135 into 0.005. So this is going to be half and more than that. Half of 135 is 67.5. Is there an answer? Okay. Second is the answer. See, I'm not multiplying it. I'm not multiplying it because when you have 0.005 and all, I took the half of this. It's 67.5. There's only one answer with 675. That is the second one. All right. So you also can do it that way. You don't always try to go to the final answer and waste your time for calculations. Right. Okay. Then the answer is second for this. Not very hard. And if you multiply that by 4, we don't have an answer like that, no, people, because we will have to, if we have taken this as the area of one leg to get the total area, then we'll have to multiply by 4. And the other thing, they haven't told what animal is there. Some animals have 2 legs, some animals have 4 legs, but yeah, I don't know. Anyways, it should be taken as total area because there's no other answer. If it was for one leg, for a 4-legged animal, you'll have to multiply that by 4. If you multiply this by 4, the answer is more than 2. So let's settle the second one. Okay. Next, let's go to 46. Question number 46. The apparent loss of weight of a metal block immersed completely in water at 30 degrees Celsius is W1. Apparent loss of weight. What is the meaning of that, people? Apparent loss of weight. Tell me one word for that. Apparent loss of weight. Call it upthrust, right? Upthrust. Apparent loss in weight is upthrust because when you weigh in air, if it shows 50 Newton, and when you put it inside water, if it becomes 40 Newton, there's a reduction of 10 Newton, and that reduction is what you call upthrust, apparent loss of weight. That 10 Newton is loss. Completely what? Okay, 30 is W1. At 30 degrees Celsius, it's W1. When the temperature is increased to 50 degrees Celsius, that reduction is W2. And the linear expansivity of metal is alpha, and the volume expansivity of water is gamma. The ratio W1 over W2 is equal to. Interesting. Now, the metal is kept completely immersed in water throughout. So, no need to waste our time. Uh, Directly, we can go to the upthrust equation. So, at 30 degrees Celsius, first of all, right? Let's say the metal has a volume of V naught and the liquid has a density of rho naught. Okay, and then there's an upthrust. That upthrust is only W1. Apparent weight loss is upthrust. And the equation for upthrust, usually people, that is submerged volume into density of the liquid into G. So W1 is equal to submerged volume is V naught. Total volume is submerged now. Completely, immersed completely, see? And the initial density of the liquid, will take it as rho naught. All right, we'll take it as rho naught. And G is G, right? Yeah. And then they are immersing it at 50 degrees Celsius. Now the metal will expand. They have given the linear expansivity of metal, so the new volume of metal will take it as V. And at 50 degrees Celsius, new temperature, let's take the density of the liquid as rho. And the new upthrust is acting now, that U, W2. The new upthrust is W2. So we have already defined the definition for upthrust. W2 is equal to V rho G. So when you combine these two equations, what do you get? We are supposed to find out W1 over W2. Yeah. So when you divide them, you will be getting W1 over W2 is equal to V naught over V into rho naught over rho. G will get cancelled out. And this is going to be our focus. All right. Fine. Let's finish it off. Should not be a problem. First start with the metal. For metal, what can I say? For metal, the equation we can write is the volume expansion equation. New volume is equal to initial volume into 1 plus 3 alpha delta theta. Hope you can agree with me on that. 1 plus 3 alpha. We don't put gamma. Instead of gamma, you can put 3 alpha. Okay, never mind. If not, I say gamma delta theta. That is equal to V naught bracket 1 plus. Instead of gamma, you can put 3 alpha into what is the temperature difference, people? 20, isn't it? 20. Because from 30 they have increased it to 50, so 20. එතකොට උත්තරය මේ P equal to V naught bracket 1 plus 60 alpha. So that gives us, we need V naught over V. Therefore 1 over 1 plus 60 alpha is only V naught over V. Right. And then let's go for the liquid, for water. For water, hope you can remember the equation. Density is given by rho equals rho naught bracket 1 plus gamma delta theta. 1 plus gamma delta theta. And we are supposed to find out rho naught over rho to get the final answer. So 1 plus gamma delta theta is equal to rho naught over rho. And delta theta once again is 20. Therefore, rho naught over rho is equal to 1 plus 20 gamma. 1 plus 20 gamma. Therefore, the final one, W1 over W2, that is equal to V naught over V multiplied by rho naught over rho. V naught over V is 1 over 1 plus 60 alpha. Rho naught over rho is 1 plus 20 gamma. So what's the final answer? 1 plus 20 gamma divided by 1 plus 60 alpha. Second one. Right? Second one. Good. Right. So hope that's also fine. If you have any problems, please stop and ask me. Yeah. Good. And let's move on to the next one. Question number 45. A small drop of oil falling in air. Now this is viscosity. Some of you might have not learned, so please bear with me. A small drop of oil falling in air has the terminal velocity of 4 into 10 to the power minus 4 meters per second. 4 into 10 to the power minus 4 meters per second. What is the radius of the drop? Coefficient of viscosity of air is 18 into 10 to the power minus 5 and density of oil is 900 kilogram. Okay, that. Right, so if you go to that equation, people who have done this might remember this equation. What is the equation, people? V terminal velocity is equal to 2g Tell me if I'm correct, huh? 2g over 9 eta into rho minus rho L. Is that the equation? Rho minus rho L. Is that the equation? I'm missing something here. I can quickly derive it and get it. 2g r squared.
So 6 pi eta RB.
You can
2R,
use that. Thinking of the final equation for terminal velocity.
2R squared G rho minus rho naught over 9 meter.
Okay, right. So only r squared was missing, yeah? Yeah, this is the equation. All right, so it seems like some of you can't remember this equation. So let me quickly explain that uh, from the basics then quickly, right? So we know when the object is falling under terminal velocity, its weight should be equal to the upthrust and the drag force. So upthrust acting on the fluid is, I'll directly write it, 4 by 3 pi r cube rho air, right? Rho air, because air is the fluid around it, g, that is the upthrust, plus the drag force is 6 pi eta r vt, equal to the weight of the fluid is 4 by 3 pi r cube density of oil, that's the weight, into g. And you can get rid of pi, you can get rid of one of the 2's here. This becomes 2 here, this becomes 2 here, this becomes 3. And what else can we get rid of? You can get rid of arch r, right? One r here. So this becomes r squared, this also becomes r squared. And then if you make Vt the subject, you will get that equation, yeah? It's better if you can remember that equation, guys, so that you can save a lot of time. Vt will be equal to, see, you take this to the other side, you have 2 by 9, this 3 goes, so whatever I wrote earlier, 2r squared g yeah, g is there, g rho minus rho L over 9 eta. This is the equation for terminal velocity. So this, if you can remember this, it will come really handy. It will save a lot of time. If not, if you can't remember, how long did it take for me to derive this? In less than 30 seconds. You can get it done. Okay, then it's just the matter of substituting the values. And which answer are we getting? What are we supposed to find out? Radius r is what we are supposed to find out. So I'll substitute the values. Vt is 4 into 10 to the power minus 4, okay, equal to 2 into r squared into g within bracket rho. Rho is, yeah, density of oil is that. What about density of air? They have ignored it, no? Density of air. Looks like that. Yeah, upthrust is normally ignored, no? When something falls in air, we know no upthrust. Within 900, just put 900 there. Over 9 eta. Eta is given 18 into 10 to the power minus 5. Right. So we need to simplify this and get our final answer. Doesn't look hard because I think all the values are getting cancelled, or most of them. Let's see. What? This 2 and this 18, we can make it 9. So, yeah. And but I have a concern with this 10. Will it be a problem? No, right? Okay, then we'll make r the subject, r square the subject. R square is going to be equal to 9 into 9, 4, 10 to the power minus 5. Another 10 here, 10 to the power 6, 10 to the, okay. So this goes up, 10 to the power 6 goes to the other side, becomes 10 to the power minus 10. So I have 4 into 81 into 10 to the power minus 10 into anything else? No, that's all. And then you divide it by, I have a 900 here. And r will be equal to square root of all this. 2 into 9 into 10 to the power minus 5 over square root of 900 is 30, isn't it? 30. So r equals 2 into 9 over 30 is 3 over 10. 6 into 10 to the power minus 6. Third answer. Third is the answer. Very easy question. If you can remember this equation, then it's very easy. Just have to substitute the values. If not, you can derive it, but you have to be a little careful when you substitute the values. And when you, now there's none of above also, people. Imagine you make somewhere mistake and you get the answer 10 to the power minus 7. 6 into 10 to the minus 7. So you will think, ah, none of the above, so answer is not there. This is very rare in the final papers. Very rare in the final papers. They don't give none of the above. They don't normally give like that, but in case, right? Good. So I recommend you people to remember this. Don't ignore this equation. Try remembering this. When a spherical object is falling under gravity, but normally you can apply Stokes law for small spherical objects, I think. So it's okay. And the other thing, sometimes they will give you the mass of the object directly. If they give you the mass of the object directly, you can't use this. So this doesn't work for every situation. If they have given the mass as m, this won't work. If they have given you radius and density of object, density of the liquid and everything, this really works. And in this case, I have taken the density of air, liquid in the sense the fluid in which the object is falling, it is almost 1. Air's density is 1 compared to 9 is negligibly small, so we can ignore it. Good. Let's move on to question number 44. Right. Okay. I was not talking to you people much. How many of you tried 45 and got it correct? Let's see. People who have done properties of matter. Okay, good. Alicia has got it right. Nice. Okay, good. Question number 44. A metal rod is heated to increase its temperature by theta from the room temperature and it is allowed to cool after clamping its two ends, which one of the following gives force F in the rod. Okay. Where E is the Young modulus of the material of the rod, A is the cross-sectional area of the rod, alpha is the linear expansion of the rod. Right. I don't know how many of you know this equation. Now, there is an equation like this: F over A equal Young modulus change in length divided by initial length. This equation we study under properties of matter. Now, 2021 batch, how many of you have seen this equation? Put your hands up. 2021 people, how many of you have seen? I think you must have seen this in this waves lesson also, because waves lesson, yeah, okay, most of you have seen it. Good. Waves lesson, there's an introduction to Young modulus, no? Speed of longitudinal waves. So during that time this must have been explained to you. Someone must have explained it to you, right? So that means you people know about this. Good. And then they are talking about alpha, the linear expansivity and all, and there the equation is change in length. We say it's what, L naught alpha delta theta. L naught alpha delta theta. So we need to find out the force. So let's continue here. Instead of delta L over L naught, I can directly substitute what, alpha delta theta. Therefore F over A equals E alpha delta theta. Therefore, F is going to be equal to EA alpha delta theta. You must have tried this question. It's a past paper question. It's a past paper question because second is the answer. Right. Good. Then let's move on to 43. Question number 43 is about magnetic field. Again, issues, right? Two long parallel wires P and Q are held perpendicular to the plane of the paper and separated by a separation of 5 meters. If P and Q carry currents 2.5 amperes, 5 amperes respectively in the same direction, then the magnetic field at the point midway between P and Q is interesting. Two wires separated by a distance of 5 meters. Wait. So I'll use two different contrasting colors to show them like this. Okay. So in this current, I'll take it as 5 ampere. Same direction, that's very important. Same direction. In this one, the current is 2.5 ampere. 2.5 ampere. What the direction is important because magnetic flux, magnetic field means indirectly they are asking for the magnetic flux density. B is what they're asking. B is a vector. So direction is important. All right. B is a vector. Right. So because of the orange color at the midpoint, because of the orange color wire, there's going to be a magnetic flux density into the plane, because you have to direct your right thumb, you have to use right hand rule to find the direction. You have to direct your right thumb downwards, and then so other 4 fingers will be directing into the plane. Therefore, here there will be a magnetic flux into the plane due to the orange wire. Mark it in orange color, B1. And due to this one, it will be out of the plane. it will be out of the plane, and that will be B2. So the resulting magnetic flux density will be, B is actually going to be equal to what? B1 minus B2. B1 is going to be larger because current is larger. Current is larger, right? And the distance between these two, it's a midway point. They are saying it's midway point. So the total separation was given as, total separation was given as 5 meters. That means at the midpoint it should be 2.5 meters and 2.5 meters, right? And the equation for B, when there's a wire infinitely long wire, and from that wire at a distance of r, the equation for B is given by mu naught I over 2 pi r. People who have studied it should have done it. No, Shimmer, we haven't done this at the class yet. If you haven't done magnetic field anywhere else, then it's difficult for you to do this question. We'll be doing it tomorrow. Right. And then continuing, moving on, right? So the equation for B1 now, B1, that is going to be mu naught I, mu naught into, what is the current due to this one? 5 ampere divided by 2 pi into 2.5, because the distance is 2.5, not 5, careful, midpoint, minus B2. What is B2? Current is mu naught into 2.5 divided by, again, 2 pi into 2.5. The final answer is, the denominator is same. It is going to be 5 pi in both. 5 mu naught minus 2.5 mu naught. Answer is 2.5 mu naught divided by 5 pi. Therefore, mu naught by 2 pi is the final answer. Third one. Third one. Right. Is that the answer given in the scheme? Anyone, can anyone check and confirm it, please? Yeah, okay, thank you. Right. So, yeah, this is the one. Right. So people who have done it, it's a good question in my opinion. You know why? If you by mistakenly add them, 7.5 over 5, is there an answer? Yeah, fourth, you might have got fourth. So you should have been mindful about the direction as well. Direction that instead of 2.5, you put 5 and all those things. So, right. That's done. Then move on to the other parts. Right. So we kept the others waiting. Hope. Right. Looks like the other questions are mainly from other units now, people, the latter part. Right now, since we have done some questions from behind, we have covered actually 8 questions from behind. I'll go to the front part. Okay, let's go to the front part again, because I feel like some of you, there are some of you who haven't done anything in a sense, who haven't covered these parts. So let's quickly go through the first few really quickly. Starting with the first one, the unit of moment of inertia, second one. That's just a piece of cake. Second one, and this. So unless they have mentioned it as infinite long, we should consider them finite. If it is finite, they will mention it. Who is that, Madhushan? If it is finite, they will mention it. If they haven't mentioned it, you take it as infinite, the wires. She's asking a question about magnetic field, because if they have given a finite length of a wire, then from that finite length of wire, the equation for B is given by Biot-Savart theorem, mu naught I delta L over 4 pi r square. Hope you can remember this. This is the equation. And this length is delta L. So if it is finite, if there's a finite length, they will definitely give that. Go check A level 2009. I can remember very well because that's my paper question. I can't remember the question number though. In A level 29, I think this is the only question where we have in MCQs where we apply this Biot-Savart theorem equation directly, right? And we derive the other equation based on this. Fine. So have a look at it. Have a look at it. If it is finite, if it is a small piece of wire, they will mention the length. If not, you take it as an infinitely long wire. Right. Okay. First one, very obvious. It's moment of inertia, kilogram meter square. Second one, the sum of two forces acting at a point is 16 Newton. The resultant force is 8 Newton, and its direction is perpendicular to the smaller force. Then the force Ah, right. So there is one force like this, one smaller force, and this is one of the forces, and the resultant is 8 minimum. Resultant is 8 Newton, uh, and they are asking for the other the two forces. So if you take this as x, so how should have been the other force? If you are getting the resultant like this, we know we can complete the parallelogram because it's based on parallelogram theorem. People, this is the diagonal. This is one side, and this should have been the other side. So I can draw a parallel side here, and then another side parallel to this x. So the other force, the next force we are looking at should be the one I just drew. This one. It should be the next force. This should be the next force. Okay, and this should be 16 minus x, because total as sum is, when you add this force and this force, it is 16. So if it is f1 is x, then this should be 16 minus x. Right. If this part is 16 minus x, this also should be 16 minus x, because they are parallel. Completing the parallelogram. This is it. Two forces acting, they are resultant. Right. Now, when you have 8 here, perpendicular here, then what is the answer? When you look at this, it should be first one. Now, why do I say first one? Because according to Pythagoras theorem, we know we can think of this, right? 6, 8, 10. 6, 8, 10. When you have 8 as one of the sides, and when you have drawn right angle triangle, this should come to your head, obviously. All right. How did I get this? That came from 3, 4, 5. Tunahatrapa. Multiply everything by 2, you get this. All right. Right. So there's no point of you putting square Pythagoras theorem. Don't apply it and make it ugly. Don't make a mess out of it. Just try to get this relationship. So definitely 6 and 10 should be the answers, because when you add them, it should be 16, and all three of them should be able to obey Pythagoras theorem. All right. Fine. So raise your hands if you did this way without going for the equation. Now, what is the equation? 16 minus x whole thing squared is equal to 8 squared plus x squared. Ammo can do anything, but try not to do that way. Right? It's not wrong. Still get the answer, because x squared gets cancelled off. But it's better if you can find it this way. Anyways, you might have ended up in this answer. This is very easy. Non-viscous incompressible steady streamline flow. Now we know here speed is high. Here, no, the other way around. Here speed will be low because of high area. Here speed will be high. If the speed is low, then we know the static pressure is high here, and here the static pressure is low. The graph shows of correct variation of static pressure. That's very important. Static pressure. Therefore, the answer is going to be high pressure, static pressure, low static pressure. Static pressure, here pressure, low pressure. Therefore, second is the answer for third one. Okay. In case if they had asked for the diagram for dynamic pressure, what do you think will be the answer? Dynamic pressure. What is dynamic? This is static pressure, people. What is dynamic pressure? What kind of graph do you expect if P had been dynamic pressure? Dynamic pressure is our half rho v square. Half rho v square. That is dynamic pressure. Static pressure is P. Total pressure head is constant. That's different. P plus half rho v square. The whole thing is constant. Dynamic pressure means half rho v squared alone. This is what you call dynamic pressure. Okay, so wherever the speed is high, the dynamic pressure will be high. Wherever the speed is less, the dynamic pressure will be less. So the first one, if it had been dynamic pressure, right? So just to give an idea, because sometimes they might confuse you, always be mindful about the adjective. If they don't mention whether it's static or dynamic, then we normally take it as a static pressure. All right, fine. Then let's move on to the next parts. Fourth one. We take the fourth one. uh, the cylinder tube of a spray pump has a radius of r, one end of which has fine holes, each radius r. If the speed of flow of liquid, now this is the gun, so here it's like this, and the other end it has another opening like this, and there are small holes like this in that. Okay, so here you will have a volume flow rate, actually speed v, and out of these, each of these holes, the liquid will come out at a different speed. I'll take it as v dash. All right, fine. And there are n number of holes. Then the plan, your plan should be this: the volume flow rate out of this, we'll take it as q1, and volume flow rate out of a small one, we'll take it as q2. So you have to start it this way. Q1 is the total volume flow rate coming in. That will be equal to n q2. From each hole, the volume flow rate is q2. You have to multiply by now n. And q1 is what? Q1 is a1 v1. I'll write it that way. A1 v1. Q2 is n a2 v2. So a1 is pi capital R squared v equal to n. A2 is pi simple R squared, and v2 is what we are supposed to find out, v dash. Hope you can understand that. Right, so pi will get cancelled off. Pi will get cancelled off, and finally you will end up v dash is actually equal to r squared over simple R squared into v over. What is the answer, people? Do we have an answer like that? I can see v over n. Fourth one, isn't it? Fourth one, no? Fourth one. Because we have v over n, r squared over simple R squared is given as capital R over simple R, whole thing squared. So it's check. Right. Fifth one. The end correction of a one end closed tube of length 58 centimeter is 2 centimeters. The speed of sound in air was 300 meters per second in a temperature 27 degrees Celsius. Then frequency of the fundamental mode of vibration of air column. On another, something is missing there, data. Frequency. Frequency of fundamental mode of vibration air column. On another day, higher temperature, the both ends of the tube were opened. Then the frequency of fundamental mode was F2. So this must have been F1. The frequency of fundamental mode of vibration of air in the column, here let's include, was F1. That is missing, I think. F1. Yeah. Right, F2. The speed of sound in air was 310. Okay, F1 and F2 are. Two situations, we have to analyze them quickly, separately actually. First situation, at 27 degrees Celsius, you have a tube, one end closed, and you get the fundamental mode. This is the fundamental mode, and the length is 58 centimeter, and the end correction is also given, L and E. So we know the whole length is actually equal to lambda by 4, and lambda by 4 is equal to L plus E. And lambda is equal to 4 L plus E, where L plus E is 58 plus 2. So that is 4 into 60 over 100. Hope you can understand what I've done. I've converted to meters. Final answer is 2.4 meters. That is what lambda is. L is 58, E is 2. 2.4 meters. And for that instance, I think we can apply V equal F lambda. V is 300, F is F1 into lambda is 2.4. F1 is equal to 300 divided by 2.4. In 2.4, I can see a 3 there. So 100 divided by 0.8. 1000 divided by 8. 1000 over 8 is 500 over 4, 250 over 2. 125. And there's only one answer with 125. F1 and F2. First is the answer. Don't do and find the second one, if you are absolutely sure. Right? First one is the answer. But let's say you are you want to be absolutely sure, and in the final paper, most probably they might not give an answer like this. So there will be another answer with 125, 500, something like that. So let's try to be absolutely sure about this. There, what's happening at 310 degrees Celsius. both end are open now, right? Once you open both end, and if the fundamental mode, the vibration is happening at fundamental mode, what's going to happen now? You'll have two end corrections on either end now, and the length is in the middle, L, E, E. And what is lambda, guys? The total length now. Total length is going to be lambda by 2, and that is going to be L plus 2E. Therefore, lambda is equal to 2 L plus 2E. Lambda then equal to how much? 2 into total length is 58 plus 4, 62, 62 over 100. So lambda is equal to 124 over 100, 1.24 meters. 1.24 meters. And again, for this situation, when you apply V equal F lambda, V is changed because temperature is changed. The speed of sound in air depends only on temperature mainly. So it's 310 equal to F, we have to find F2, lambda is 1.24. F2 is equal to 310 to 1.24. Okay, what can we do, people? I see 31 in both of these. If I 31, yeah, because I can write it as 31,000, and this is 124. Dakota, it's like 1,000 over 4, right? 31,000 divided by 31 is 1,000. In 124, there are 431. So I'm getting 250 hertz as the answer. Yeah, first one, shape. But since only one answer has 125 as the first option, no need to do this. But if you really want to be absolutely sure, this is how you do it. Right, fine. Now, sixth one. When monochromatic light ray, monochromatic means single colored light ray travels from air to glass. Intensity of light remains constant. Intensity. I will come back to that. Frequency of light ray remains constant. That is definitely correct. Because we know when a wave travels from one medium to another, frequency doesn't change. Frequency doesn't change. Therefore, B is correct. If B is correct, this is wrong. This is wrong. Color of light ray remains constant. What happens to the color of a light ray, people? It doesn't change, right? You must have done these experiments with what do you call that, prisms and all. When you send, we normally use laser light. It will be red. It will go inside. It will come out as red. It's single colored. Therefore, it doesn't change. The color doesn't change, right? So B and C are correct. Therefore, mostly fourth must be the answer, no? Color doesn't change, people. Color, there won't be a big change in the color. There won't be a change in the color because experimentally, I think now in Gampal Zahira, I have seen that kit. I don't know how whether you people have done that experiment in the laboratory. You have this box where you have a laser light, and in that you can change. There's a small gadget where you can change different objects. You can fix a lens, concave lens, convex lens, prism, everything. And then the laser light is red in color. When it goes inside the glass also, it remains red. Color doesn't change. B and C are correct. Then there's only one option, that should be the fourth one. Because ABC is not there. So I'm intensity of light. Intensity of light. Energy per unit area. Energy per unit area per unit volume. Power over area. That we'll have to check a little bit. Intensity of light. I'll think about that and get back to you. Intensity of light. Light is actually electromagnetic wave, so we have to think of photons also. Yeah. That's it. First place statement, there's a small issue. Now, there's no question about B and C, people. Frequency of light remains constant, and yeah, that. Wait. So first of all, let's finish seventh one. I will come back to this, so that I can manage the space. So the figure shows the path of a light ray that incident on a drop of water at point A. The light ray partially reflected at point B. Partially reflected at point B. Partially reflected at point B. Partially reflected means this angle and this angle are actually equal. Emerge to air from point C. The angle of incidence is 30 degrees Celsius, 30 degrees at point A. So this I is in fact 30 degrees here. Here it is 30 degrees. R we don't know. R is what we are supposed to find out. refractive index of anything is not given, but the total deviation is given. So it's a different type of question. Total deviation is given. What should be the value of R? So you can't find R using Snell's law because refractive index of what is not given. Now, deviation is happening at how many places? Four places. Three places. A, B, C. But before that, we know this is a sphere. So this length and this length and this length are equal. Why is that? These lengths are equal. The lengths are marking, they are equal. Na, people? These are equal. Okay, so if this angle is R, this is also R, this is also R, this is also R. All these are R. And if this is R, again, this is going to be I, 30. Hope you can understand this. Because inside what R means, outside what it has to be 30. All right, good. And let's analyze now. What is the deviation at this point? The deviation at this point is the ray should have gone like this. The ray should have gone like this, but it is bending this way. So I'll take it as D1. D1. Right? Deviation, you can see it's clockwise. And at this point, the ray should have gone like this, but it's going this way. D2. Again, is it clockwise or anti-clockwise? Clockwise. So that must be added. D1 plus D2. And here also, the ray, it goes like this. Should have gone like this. If it had not deviated, should have gone like this, but it's bending this way. It's bending this way. And I'll take it as D3. It's not very clear. Right. Wait. The ray should have gone like this, but it is bending like this, and it is 30. Why is it 30? No, not 30. It is D3. The whole angle is only 30. D3, I'm taking as D3. This whole angle will be 30. This whole angle. Because I means, R means, inside what R means, outside should be I. Ri. Good. So total deviation, you can say, total deviation. Total deviation. That is equal to 150. And total deviation is in fact D1 plus D2 plus D3 equal to 150. What is D1, people? D1 is 30 minus R, right? 30 minus R. Angle of incidence into angle of refraction, 30 minus R. Plus what is D2, guys? What is D2? Anyone? This is the critical one. What is D2? What is the deviation at B? That will be good. 180 minus 2R. 30 minus R, and the other one is 180 minus 2R. Good. And at C, there also it is again 30 minus R equal to 150. Here also it's 30 minus R because the 30 R is smaller, 30 is larger, so 30 minus R, that is the deviation. Therefore, when you add everything, you'll be getting 30 plus 180 plus 30. It's 240, isn't it? 240 minus 4R equals 150. 4R, what am I writing? 4R, 240 minus 4R, that is equal to 150. You are getting 4R is equal to 90. That means R is equal to 22.5. In 88, there are 4. In the other 2 is half. So when you divide 90 by 4, if not 90 by 4 is 45 by 2, 45 by 2 is 22.5. Right. So what is the answer? 22.5. Come on, where is that? It's not there, everyone. Anyone who tried this and got this answer? 22.5? Oh. So it looks like few of you have got the answer. 22.5. So what shall we do? Okay, let's take the fifth one, no? Because fifth one is the closest answer we have for that. 21. Must have been a printing error somewhere. Let's go with 21 then. Okay. It's the closest. Let's go with 20. And is that the scheme answer? Have they given that in the scheme as well?
Yes, sir.
Okay,
Yes.
fine, right. Seventh one, and they must have given fifth then. Okay, good. Let's settle to that. Right, good. Now we are done with seventh. It's a good question, people. It's a good question. Area one, because in A level I have not seen questions like this, so it's a good one. Right, now let's get back to our sixth question. Sixth one. Problem number six now. No mail for 15th one. Okay, seventh one, fifth is the answer, man. That's what the others are saying. Check that, will you? Right now, talking about this now, people. Last year, I can remember when I was teaching this, one kid asked me about this energy. She asked me about energy, so I can remember. Amanifaz, it was Amara when she asked me about energy. What happens to energy during refraction? Energy of light during refraction. So let me give you a thorough explanation about that. Mehamane, when you take light ray traveling from one medium to another, okay, light ray traveling from one medium to another, let's assume that light ray is traveling from a denser medium to rare medium. So it will do this now, even light ray. So I'll go with orange for light. Denser medium to rare medium. Okay, denser medium to rare medium. Right. Then it will light actually travels like this, even though we don't draw it this way. Do you agree with me? What am I drawing here for light? I'm drawing light like this. Who are these people? Who are these?
Photons.
Yeah, these are photons. We never draw them like this. We never draw them like this, photons. And then these photons, some of the photons, let's say they go this way. And some of the photons, what do? They get partially reflected. I mean, this is not how it happens. It will continuously flow. So let's say at a given time, 10 of them enter the surface. It's completely hypothetical. Huh? Let's say 10 came towards this boundary and all 10 won't go in, right? But frequency will be same because all these photons will have the same frequency. Photons can have the same frequency. That's not a problem. Frequency will be same. But what will be different? Tell you? What will be different then? All of them will have the same frequency. What will be different? But what will be different? The total energy will be different, people. The total energy will be different. Tell me why. Here the energy will be energy 1. If you take energy 1, what is the energy value? 10 HF. Got it? 10 photons approaching the medium and only I'm scribbling like let's wait. The energy entering the medium is 10 HF. I've taken hypothetically 10 of them are entering. 10 HF gattana. All 10 photons don't enter the other medium. I have taken 6 of them entering the medium. So here the energy will be 6 HF. And the energy of the light reflected will say, for example, 4 HF. Got it? So the frequency still can remain the same. Now you can't argue like this, sir. E is equal to HF now. So if frequency is constant, energy must be constant. That's the argument she had. It's a very good question. It's a very good question. But energy is quantified. It's not continuous when it comes to electromagnetic waves. This is what Einstein figured out. All right. So it can have the same frequency, but the energies will be different because you have to add all the energies of each photon and only get it. Okay. Right. So energy is changing. No? When light travels from one medium to another, energy is changing. This is wrong. First one is wrong. It will not remain constant because intensity is equal to energy over area. Energy over area into time. So if energy changes, intensity will change. Intensity solely depends on energy. Okay. Right. Fine. Malaysia, did you understand? You had sent me a message, long one.
Yes, sir.
Okay. Right. That's what happens here. Done then. Let's move on to the next ones quickly. These ones. Right. This should not be a problem, I think. Third, na people, eighth one. O level, ne? Third. Third, ne? Wait. No. Not third. Second, no? Second, sorry. Not third. In third, it's converging. It's a glass lens. Careful, huh? It's a glass lens. In case if they had mentioned AR lens, they are inside AR cavity, then you have to think of the opposite. This is correct. This had been AR and this had been glass, this is correct actually. But they are talking about glass lens, so it's just very conventional, becomes an O-level question. This is the one, but this is you have to decide this based on the reversibility of light, right? You have to decide this based on reversibility of light, because when light approaches a concave lens, what does it do? It diverges. This is how we normally draw. If you change the direction of the arrows, then you will be getting this. Light can do that. It can take the opposite. It can take the reverse path. So this second is the answer. Ninth one. මෙතන පොඩි ප්‍රශ්නයක් තියෙනවා. Ninth one, with the period of time of simple pendulum is 4 seconds. The amplitude of oscillation is 4 centimeter. The velocity of pendulum bob in centimeter per second. So horrible printing errors are here. Centimeter per second. Now, what is the problem in this question? Tell me. What is the word missing here? One word is missing. What is the word missing here? Don't know whether you people just did the question. There's a word missing here. Good. Not simple harmonic motion. It should be maximum velocity. They should have asked about maximum velocity. The maximum velocity of the pendulum, because the equation for velocity is this, people. Equation for velocity of an object performing simple harmonic motion is given by omega square root of a squared minus omega squared. This is the equation for velocity. So velocity is not constant. It changes from point to point. There are points where velocity is 0 also. So they should have been specific, and it should have been maximum velocity. Yeah, right. So for maximum velocity, you know the equation. What is it? Velocity maximum is equal to amplitude into omega. Amplitude is given 4 centimeters. It's 4 centimeters into omega. Well, they have given the period of time. Omega is 2 pi over period of time. 2 pi over 4. Second minus 4. So final answer, 4 and 4 gets cancelled off. 2 pi centimeters per second. They have ignored the radians part. We don't normally put it when you say maximum for velocity. Answer is third one. A squared minus x squared. Yeah, sorry. A squared minus, what have I written there? A squared minus x squared here. I have a spot here in my laptop. I can't see what I have written. Equation for speed is this. V equal omega square root of a squared minus x squared. This is the equation for speed. So I wrote this to show you that speed of the object changes with displacement. X, omega and a are constant, but as x changes, we will change. 2 pi. 10th one. What about 10th one, people? When a mass of m0 is suspended from a helical spring constant k0, the extension is delta L. Right. So the spring is there, nothing is hung, and then when they hang a mass of m0, there is an extension. Then the weight is force is m0 g, and the extension is given by delta L. F equal kx, F is mg, m0 g actually, equal to k0 delta L. K0 is going to be equal to m0 g over delta L. They have given this, so let's keep it as a separate thing, right? We might need it later. That mass m0 is pulled down by a small distance delta x0, and released to give simple harmonic motion. What is the frequency of this motion? Right. Now we haven't studied, I don't know whether you can remember, you might have done this at your theory classes, but normally the equations we know are now T is equal to 2 pi root of L over G. T is equal to 2 pi root of M over K. These are the equations we normally remember. And there's an equation for upthrust that actually I can't really remember quickly. I can quickly derive it and get it. So my point is, this equation is something unconventional, little different, right, from what we have got. So let's see what this is all about. Then simple harmonic motion, when it comes to simple harmonic motion, people, there is a force called restoring force. No? Restoring force is equal to what? Minus ma. That is where we start. Restoring force is taken as minus ma when you apply it to F equal ma. All right. So here the restoring force, that means the additional force. The additional force, not the total force acting on the object. The object was at equilibrium here. When you make a small change, there is an additional force created on the object, right? So what happens there? The additional force created on the object is delta x is the further extension in the length of the spring. Therefore, the additional force is k x naught. Hope you can understand that. Restoring force is the additional force created. All right. Now, imagine when there's an object is floating on water, when it floats on water, it won't do anything. But if you press it a little bit, if you press it by a distance of delta x, then after that it's going to perform simple harmonic motion. What is the restoring force for this instance? If restoring is going to be change in upthrust. Change in upthrust is the additionally submerged length multiplied by area will give you the additionally submerged volume density of the liquid G. That is how you have to start the argument. Here also same thing. Additionally created force, that is kx naught equal to minus ma. And what do we do in simple harmonic motion? We make a the subject. When you make a the subject, it will be minus k over m into x naught. So you have to compare that with a equal minus omega square x. So that gives you omega square is equal to k over m naught, in fact m naught, sorry, because the mass is m naught, no people, m naught. So omega is equal to square root of k over m naught. Then what are they asking for? What is the frequency of the motion? Frequency of the motion is f equal 2 pi, no wait, what? Omega equal 2 pi f, isn't it? Omega equal 2 pi f. That is f equals 1 over 2 pi into omega. That is 1 over 2 pi. Omega is square root of k over m naught. But unfortunately, k naught, in fact, k naught, they are using the value k naught, everything k naught. Right, k naught. K naught of m naught is not there in the answer. For that only, we will need this equation, yeah? So you can say k naught of m naught, that is equal to g over delta L. That will be 1 over 2 pi square root of, instead of k naught of m naught, you can put g over delta L. Therefore, the answer is third one. No, second one, because in the third one, 2 is missing. Second one. Right. So that's the answer for the 10th one. Huh? Good. Done. Yeah, you can. You can use one over t also. You can use 1 over t. Same. You'll get the same answer. Okay. Then the next part. A tuning fork of frequency 260 hertz vibrating with another tuning fork. A tuning fork of frequency 260 hertz vibrating with another tuning fork A gives 10 beats with 1 second. So when you say 10 beats with 1 second, beat frequency is 10 over 2. 10 beats with 2 seconds actually. 10 over 2, that is 5 hertz. All right. During the second time of vibration, part of a prong of A was broken. So if prong of A was broken, it will be like this. It becomes this. What will happen to frequency of A? So frequency of A will
Reduce.
sorry.
Increase.
Yes, it will increase. Why does it increase? Because its size reduces. When the size of a tuning fork reduces, the frequency will increase. Okay. So the number of beats became 18 by 18 within 3 seconds. So there are the new beat frequencies 18 over 3, 6 hertz. So beat frequency has increased. The frequency of the tuning fork A should be. Now, first of all, yeah. So there's this fixed tuning fork of 260 hertz. All right. With that, they are vibrating A. When A is vibrated, the beat frequency is 5 hertz. What is the meaning of that one? A could be 265 or A could be 260. Both are possible. 260 and 255. Both are possible. I hope you understood it. Both are possible. Okay, right. Now, wait. Sorry. Both are possible because so A could be these two. We don't know. A could be these two. It's either 255 or 265. Ah, okay. Then only 265 is there in the answer, na? Then this question is nothing, people. Ayyo. Yeah. Boring. Let's try to find out the frequency of A after it's broken. The frequency of tuning fork A after the prong was broken. Let's try to find that now. All right, we'll do it that way because this question is nothing. Right. So I just improvise. Can you tell me the answer now? I'll change the question. The frequency of tuning fork A after the prong was broken. Now tell me the answer. Give me 2 minutes.
266.
Okay, I've got one answer. Anyone else? The question is you have to find the frequency of A after the prong is broken. Right, good. Now, then if A, I said A could be 265 or 255. A could be 265 or 255. Once the prong is broken, frequency of A must have increased. So it should have gone somewhere higher here. From 265, it should have gone to 267, 260, something like that. And here, it should have gone to a higher value. From a lower value, it should have 255, it should have gone to higher value. Right. So this gap is 5 now. This gap is 5. This gap is 5. This gap is 5 hertz. This gap is also 5 hertz. But here, after the, if 265 was the value, then the beat frequency should be a value higher than 5 because the value of A is increasing. But if 255 had been the frequency of A, the new beat frequency should have been less than 5. But the new frequency is how much? Greater than 5 because it becomes 6. Therefore, definitely the answer should be earlier frequency is 265 and the new frequency must be how much? 266 hertz. From 260, earlier one was 5 hertz and then the new one is 6 hertz, the beat. So 266 should have been the answer for this. Now, yeah, since I've changed it, I'll just mark third one. But according to the question they had given, it should be the first one. But I don't think at the advanced level they will give us a silly question like that. Fine. And moving on to the 12th one. When the vehicle B is passing point C, the frequency of sound emitted by B observed as if not by the observer A. When B comes to D, the observer, now there is a problem with this question, people. A must be very close. Think of A as a passenger in a platform and the train is going. If not, if the object is at D, now they should have given these angles and all those things to find the proper answer. So I think this is what we have to assume. When the vehicle vehicle is at C, there will be no Doppler's effect. That's how we consider because they are like at say no Doppler effect. But when the vehicle is at D, vehicle moving away, let's take it that way. Right? So at C, if there's no Doppler's effect, frequency heard by A will be how much? Frequency heard by A will be equal to F naught itself. I mean the frequency of the vehicle. And now the vehicle is moving away. So frequency at D, when the vehicle is at D, to speed of sound in air divided by speed of sound in air plus speed of original frequency of the source. Now I normally use C for the speed of sound in air in my equations, and observer is at rest. No, people. Observer is not moving. It's like moving away, right? Okay. So speed at frequency at D is and C. The speed of sound in air is given as V over V plus Vs is the speed of the source into F naught. So how do you simplify it? F naught and F naught can be cancelled out, and you cross multiply it. When you cross multiply plus 4Vs equals 5V, therefore Vs is what we are supposed to find out. V over answer is third. This is how you have to do it. Think of these just going away, but in then only you can find that theta, V cos theta, but they have not given any information like that. So let's skip this way. Okay, I hope you people also did it this way. Huh? Right. Of length 100 centimeter and mass 20 gram is stretched to a tension of T naught, and it's vibrated transversely from 0 hertz to 100 hertz. The first resonance rate was not observed, but the next two resonance state 60 hertz. So 40 hertz is this. 60 hertz is this. 3F now. This is 40. This is 60. That means F naught is 20 hertz. F naught is 20 hertz. Now for F naught, the equation is 1 over 2L square root of T over L. This is the equation you should be using for fundamental frequency, right? F naught equal 1 over 2L square root of T over M. What is the tension? They're asking for the tension. Now, M is not given, but you can find them. No? You can find them because length and mass are given. Mass per unit length of this thing. So F naught is 20 equal to 1 over 2L. 2 into 1. Why did I put 1 here? The reason for putting 1 is it's 1 meter. 100 centimeters, 1 meter. One meter. 1 equal to square root of T we had find out divided by mass over length. Simple M is mass over length. So that is going to be 20 gram divided by 100 centimeters. So that is 20 gram, 0.02 divided by 0.02 divided by 1. All right. Then either side must be squared. I think this 2 goes up. You get 40 here equal to square root of T over 0.02. And 1600 equal to T over 0.02. Answer is 32. Fourth one. No? Answer is fourth one. No? Right. Next one. The sound intensity level at a point 10 meter from the sound source is 50 decibel. What is the sound intensity level at a point 100 meter away from the source? Now, when you compare the sound intensities from at 2 points, now this is the source, and you take point A, and then you take point B. All right. I said this distance is RA, this distance is RB. Remember this, then it's easier for you. Whenever they talk about sound intensity level, from the source at a point, you define two things: sound intensity and the corresponding sound intensity level. Here, sound intensity and the corresponding sound intensity level, beta B. Right. and the distance is RA and RB. RA is going to be 10 meters, the what do you call that, the closest one, and then 100 meter from the source. So RB is going to be 100 meter, the further one, right? So we know IA is going to be bigger than IB. Closer you are to the source, louder will be the sound, right? Stronger will be the sound. And now there's an equation like this, people. Now beta A is larger than beta B, obviously. So you can write beta AO minus beta B equals 10 log IA over IB. I hope you all can remember this equation. And there's another one you can add to this, that is 10 log. Instead of IA over IB, you can write RA squared over RB squared as well. Try to remember this. Okay, I hope you can relate to it. Why is that? Because I is equal to power over area from a point source, power over, for area you can put 4 pi r square. That will give you intensity. Sound intensity is proportional to 1 over r square. 1 over r square. Therefore, from that we know I1 is proportional to 1 over r1 squared. I2 is proportional to 1 over R2 squared, and from that you will be able to get an equation I1 over I2 equals to R2 squared over R1 squared, the opposite. And if you can remember that equation, it will be very helpful for you when you do questions at the exam, because it will save you a lot of time. Save you a lot of time, because we have to find the connection between sound intensity level and distance. Right? So let's say now we have figured it out. We don't remember that. So sound intensity level at 0.1 minus sound intensity level at 0.2, that is equal to 10 log. If beta 1 is larger, that means R1 should be smaller. So it's going to be R2 squared over R1 squared. Look at the equation. I think here I have made a mistake. It should be RB squared over RA squared. Smaller will be the intensity. So smaller resistors must be put closer. Can use this one. Yeah, right. Then it will be 10 log R2 squared to R1 squared. What can you put there? R2 squared, that is 100 squared. 100 into 100 over R1 square is 10 into 10. That is actually log 100 then. See, 10 and 10, it gets cancelled off. This gets cancelled off. So log 100 is 2. Log 100 is 2, 10 into 2 is 20. 20 is the difference. Beta 1 is beta 1 is 50 minus beta 2 is the new one, that is equal to 20. Why did I put beta 2 minus? Because beta 2 is at 100 meters away, so it should be a lower value. Therefore, beta 2 is how much, people? Come on, this is 20 here. 20. Beta 2 is 30. 30 decibel. Beta 2 will be 30 decibel. Okay, fine. 30 is the answer for 40. Question number 15. Okay. A telescope is constructed by using two convex lenses of focal length 100 centimeter and 20 centimeter. When it is used to observe an object at infinity, its final image is formed at infinity. So they're talking about a normal adjustment, right? Suddenly he adjusted the telescope to form the final image at his near point. The least distance of distinction is 25 centimeters. So his near point is at 25 centimeter. What is the separation between the lenses? Okay, a conventional telescope question, a quick revision. Right. Now what do you do in these cases? Two lenses are there. Now there are two lenses. They have not mentioned who is who. You should know the lens with the highest focal length should be the objective lens. Right? Okay, so the object is at infinity, therefore you know what will happen for the image. You will get the image at the focal point of the object lens, the first image. Okay, and this distance is going to be how much now? 100 centimeter. because the object is at infinity. If the object is at infinity, the image will be formed at the focal point of this lens, f naught. And the final image is formed at 25 centimeter. Final image. It's formed at 25 centimeter because that is the uh, least distance of distinction. I'll take it as VE, the image distance for eyepiece, and the focal point of eyepiece should be somewhere here, because this image created by object lens becomes the object for this and this. Okay, then to find out, we are supposed to find out what is the separation between the lenses. Separation between the lenses. For that, we need to find out 100 plus this distance, that is UE. So we need to find out UE. For that, what will you do? Very easy. Carefully, formula 1 over V minus 1 over U equal to 1 over F. Now 1 over V is 1 over 25 minus 1 over UE, we don't know, equal to 1 over minus 20, because in telescopes we use convex lenses, sign convention is minus. 1 over UE is equal to 1 over 25 plus 1 over 20. So what is the answer we'll be getting? 1 over 25 and 20, the LCM for them is 100, isn't it? 100. This is 4 and this is 5. And that is 1 over UE. Then UE will be equal to 100 over 9 centimeter. Now that answer is there, but that is not correct, because they are asking for the separation between the lenses, isn't it? So what is separation, people? Separation is equal to 100 plus, if not FO plus UE. That is separation, isn't it? FO plus UE. If you had added, no, that answer is not there, so you are safe. For normal adjustment, it's 100 plus 20, 120. But this is not the normal adjustment. This is the alternative adjustment where we get the image at near point. So you have to be a little careful here. FO plus UE. FO is 100 centimeter. UE is 100 over 9. 100 over 9. Therefore, the final answer is 900 plus 900 over 9 plus 100 over 9. Yeah, and the final answer is 1000 over 9 centimeters. First one is the answer. Right, put your hands up if you got this answer. Good. Should not be a problem. And most of you have got it, no? Right, good. Good. Right, and then we'll move on to the next one. 16th question. A compound microscope is used to observe a small object placed 2 centimeters away from the objective of focal length 1 centimeter. Compound microscope, telescope, then microscope. Good revision. When the final image formed at a point 25 centimeter away is observed through the eyepiece of the focal length f2, its angular magnification is 6. Whose angular magnification is 6? The whole microscopes. So capital M, which is equal to MO into ME, that is equal to 6. Okay. What is the ratio between the focal length of objective and eyepiece? F1 over F2. Okay. Right. Let's start then. And I'm not going to waste my time here. Now, I'm not going to apply this lens formula, because now if you take the object lens, okay, if you take the object lens, people, it has a focal length of 1 centimeter, and you are keeping the object at 2 centimeter. Now tell me, where will you get the image? Where will you get the image? Where will you get the image? Yeah, you get the image at 2 centimeter, exactly, because when the image is, the object is kept at 2 focal length is 1 centimeter, if also at 2 centimeter. So now tell me, what is the linear magnification for object lengths? MO is equal to VO over UO, that is 2 over 2, 1. MO is 1. All right. If MO is 1, Then now we just studied MO into ME is equal to capital M. MO is 1. ME is equal to how much then? 6. Guys, can you remember the equation for ME? Linear magnification of eyepiece. You have to know that. ME is given by D over FE plus 1. See if it rings a bell. Linear magnification of eyepiece is D over FE, right? So D is given as 25 centimeters over FE is, we have to find it. We have to find it. Plus 1 equal to 6. Therefore, 25 over FE is 5. Then what is the final answer? FE is equal to 5 centimeter. F is equal to 5 centimeter. And what are we supposed to find out, people? What is the ratio between focal length of objective and eyepiece? Yeah, okay. You can do that also. You can do that also. So I think the first one is the answer, no? Because FO is 1. It's already given in the question. FE is 5. So 1 over 5. If not, some of you might have used this also. BO over FO. I think this is the purpose. No? They are expecting you to use this maybe into D over FE plus 1 because they have given you, you can find out VO. VO is also 2. No? You put 2 here, you put 2 here, 1, you put 1 here, 201 minus here. That way also you can get it done. Right, so you had to remember these equations. You have to remember this. The idea is you have to remember these equations. I make this equation very important. Even this one. So if you can remember these small equations, people, it will save a lot of time when you do MCQs. Right. Then we'll move on to 17th. If you have any issues, stop me and ask me the problems. Huh? So how did you get this? I did like this. Is it wrong? Like that. The 17th one. The furthest point that can be seen by a person suffering from short-sightedness is placed 10 meters away from him. The lens he should use to overcome this defect is least distance of distinction is given. Now he is a short-sighted person. What is the meaning of that, people? Short-sighted means he can see objects close to his eye, but he can't see the objects far away from his eye. The meaning of that is when his eye, if you keep an object at infinity from his eye, okay, he will not be able to see it. Can't see. Can't see. But if you keep an object at 10 meters from his eye, he can see because that is his furthest point. If you keep the object at now 10 meters from his eye, can see. So the lens he is going to wear, all right, let's pretend that you don't know anything, just starting from the scratch. Some of you might have just guessed the answer by now, but just explaining with the basics. At the exam, let's say you want to do it, you can't remember anything, and you do it from the basics. Now to be able to see the object at infinity, now he wants to see the object at infinity. When the object is directly kept at infinity, he can't see. But when the object is kept at 10 meters, he can see. So what he must do is, he must wear a lens. I'll put this lens in black color, lens. What that lens should do is, the object must be kept at infinity. Because that's the purpose. You want to see something at infinity. Let's say you want to see a bus coming at infinity, means a very large distance. So you can't change the location of the bus. Bus will be where it wants to be. Right? So that is you. And what should the lens do now? It should create an image of the object where at his far point here. So when he puts on the lens, he will be looking at this. He won't be looking at this. When he removes the lens, he will be looking at this will appear to him. It will be blurry. But when he puts on the lens, he doesn't directly see this. He rather sees the image. Now he can see. This is how lens works, right? So this time the object distance is infinity and the image distance is how much, people? 10 meters. And the focal length, let's pretend we don't know f. So for this case, we can apply 1 over v minus 1 over u equal to 1 over f. 1 over v is 1 over 10 meters minus 1 over infinity. Infinity equals 1 over f. So 1 over infinity is how much, people? It's 0. That gives me 1 over f is equal to 1 over 10. Answer is f equals plus 10 meters. Plus 10 meters. Plus 10 indicates that we should be wearing a concave lens. Concave lens, because it's plus answer for F. Concave lens of 10-meter focal length. What is the answer, people? 10 centimeter. Oof. There is no use for 25, Sajida. There's no use of 25 here. If the person is long-sighted, 25 will be useful. But here the case 25 is not useful. They have just given it. Maybe to confuse you. Maybe to alter your thinking pattern. Right? I think the answer is not there. Maybe if we get rid of the C here, then second is okay. No. And now how many of you got 10 meters concave? 10 meters concave. How many of you got it? Put your hands up. Good. Right, good. So people who have got 10 meters, you have done it correctly. 10 centimeter. Why is 10 centimeter? His father's point is at 10 meter, no? 1 over F is 1 over 10. So F is 10. One over F is 1 over 10. Not F is not 1 over 10. So F should be 10 meters. The farthest point is given as 10 meters or 1000 centimeters in centimeters. Right. So for this, should have second looks the closest. No, concave 10. Two things are okay except for the unit. So second is the answer. In the scheme, what have they given, people? Scheme? They have given second. Then maybe there's a printing error. Okay. Maybe there's a printing error. Right. Hitikat hari. Question number 18. A projectile has same range R when the maximum height attained by it is either H1 or H2. The R H1 and H2 will be related as, right? Now you must have learned in projectile motion, when you throw an object at two different angles, it will have the same what do you call that, range for two different angles. It will have the same range. Must have learned this. It's a very important point you need to know. So when you take it as theta 1 and theta 2, these two angles, theta 1 and theta 2, what is the relationship between these two angles, people? The range is same. So what is the relationship between theta 1 and theta 2? They are complementary angles. Theta 1 plus theta 2 is equal to 90. Theta 1 plus theta 2 is equal to 90. Right. So they are equal to 90. Therefore, two things can be considered. Now, one is this... this. Then I can say when I throw the object at theta 1 angle, sorry, theta angle, let's say I throw the object at theta angle, and then the range will be R. And if I throw the object at 90 minus theta angle also, 90 minus theta angle also, the range will be R. That is the meaning of this. But the maximum heights will be different now. Here you will take it as H1. Here will take it as H2. Maximum heights will be different. But the ranges is going to be same. Range will be same. And what is the equation for range? Hope you can remember. Range is equal to 2u squared sine theta cos theta by g. This is the equation for range. Remember this. All right, fine. Now the maximum height here. Okay, maximum height is h1. Now we will mark the components of velocity. Let's take the initial velocity as u here and u here. What is the vertical component here? People tell me. What is the vertical component? U sine theta, isn't it? U sine theta. And at the maximum height, the vertical component is 0. Here, what is the vertical component? Tell me quickly. What is the vertical component here? If this is 90 minus theta, the other angle must be theta. Therefore, this becomes u cos theta. Agreed? It should be u cos theta. Because if this angle is 90 minus theta now, the other angle with the vertical becomes u cos theta. So when you want to find h1, what will you do upwards when you say u squared equal to v squared plus 2as? V squared is 0. U squared, you can put u sine theta whole thing squared. plus 2 into minus G into H1. H1. So that will give you H1 equals U squared sine squared theta over 2G. H1. And when you want to find out H2, you will apply the equation upwards. V squared equal U squared plus 2AS. V squared is 0. The final velocity is 0 at the maximum height. Equal to U squared is U cos theta. U cos theta whole thing squared. Plus 2 into minus G into maximum height is H2. Okay, therefore, H2 will be equal to U squared cos squared theta by 2G. So these are the two equations for H1 and H2. And R is already here. Right? Then in all the answers, they have combined H1 and H2. They have combined H1 and H2. So when let's multiply H1 and H2. When you multiply H1 and H2, what will it give you? What will it give you? That will give you U to the power 4. If not, getting a really different answer. Okay, U squared, U to the power 4 over 2G squared, sorry, 2G squared into sine squared theta cos square theta. All right, fine. And then I need to bring r in here. Now, what is r squared here? Because I think I need to square this also because everything is squared. So if you square r, from here when you write r squared, it will give you r squared is equal to 4u to the power 4 over g squared sine squared theta cos squared theta, isn't it? This. Right. So then we can substitute those values. H1, H2 equals for u to the power 4 over 2g squared. G squared is one. Okay, wait. This is going to be okay. Then what can I do here, people? There's a 1/4 here. Leave it as it is, 1/4. And from this you can write instead of u to the power 4 over g squared sine squared theta cos squared theta. What can we write? You can write r squared by 4. Correct? R squared by 4. Let's substitute that here. How did this 1 over 4 come? 1 over 2g squared. In that I have 1 over 4. Okay, I will write it again. Never mind. U to the power 4 sine squared theta cos squared theta over g squared. I'm writing it this way. And now instead of this whole thing, 1 over 4, what can I put? Tell you. U to the power 4 sine squared theta cos squared theta divided by g squared. I can put r squared by 4. So that is r squared by 16. So therefore you will be getting r squared equal to 16 h1 h2 and r, that is equal to square root of 16 is 4, square root of h1 h2 and the answer is 4th. Understood, people? So most of you had a problem with the 18th question. I explained it, right? How many of you got this answer? Oh, good. There were some who have got it. This Rifsat Ahmad is Ishafa, right? Okay. Moving on. What is the other doubt we have? I saw someone had requested for 20 second. Okay, 20 second. Before that, okay. Any other requests? Okay. Right. Someone had asked for 20th. Someone had asked for 20th. So let me quickly explain 20th. Yeah, someone had asked for 20th. It's about resistance network, right? The figure shows a network of identical resistors of resistance R, the resultant resistance of the network. Now, since they have given point A and point B, you need to find out the resultant between A and B. Okay, so you need to find ways to simplify the resistance and convert them to one single resistance. Now, it's very easy, to be honest. You have A here, and if you look at these three resistors, 1, 2, 3, dot, and this point, if you take it as a cross. This is also a cross. Why do I say that? There's nothing here. So this point and this point will be at the same potential. And this point and this point will also be at the same potential. Therefore, these three are called parallel. If three resistors are connected to 2 points, same terminals, then they are parallel. Now, if you're wondering these 2 points are different, they are different points, true, but their potentials are equal. So these three resistors are parallel. Therefore, I put a dot here. Instead of these three resistors, we can say R, R, R. So instead of those three, you can put what? R by 3. All right. And then you have another R here. And same thing, it can be done here as well. No? Same thing can be done here as well. So you can circle here, there's a circle here, and here, square here, square here. Same potential. Okay. So R, 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 3 R are parallel. Therefore, you can put R by 3. R by 3. All right. Fine. And that part is connected to B directly. And the rest, there's another resistor here connected to A. And don't forget this B. You have R. And after that, what can I do? After that, these three are in series, now people. Then A will be here and this point, and then here you can put R by 3 and R. You add everything, it will be 2R by 3 R, 5R by 3, 5R by 3. And here you have R. And here B. And this are now what? They are parallel because they are connected to A and B. A and B. These two are parallel. When 5R by 3 and R are in parallel, how do you find the resultant, people? How do you find the resultant? You can use this equation, 1 over R equivalent, that is equal to 1 over R plus 1 over that 5R by 3. So when you simplify that, I think ultimately you will end up in what multiplication or addition? So 8, 5R by 8. 5R by 8 is the answer. So first is for 20th first. How many of you managed to get that? Right, good. Okay. Nice. All right. Put your hands down. Now let's move on to the next part. Next doubt was that some of you had requested for 20 seconds. So I'll go to that. 20 second, right? 20 second, people, the problem is these numbers. Do you see what is this number? What is this value? What is this value? Is it 3 or 5? How does it look? 3, no? Looks like 3 too. 3. 3, right. Look like someone had asked about this. Yeah, 22 around 3. Keep posting your requests. If the current through the galvanometer in the circuit is 0, the current through R, right? Now current through the galvanometer is 0. Galvanometer is 0. So if the current through the galvanometer is 0, this is a 2.5. Here it looks like 2.5 to me. 2.5 ampere, right? So 2.5 ampere current is going to come here. 2.5 ampere. Then now, if the galvanometer reading is 0, guys, you know, we can write this R by 3 is equal to 14 by 7. Wheatstone bridge. This is to this ratio should be equal to this is to this ratio. Then only the current through galvanometer will be 0. So you first can find the value of R, and that will be, I think, 6. 14 by 7 is 2. So 2 into 3 is 6 ohms. R is 6 ohms. Now you have 6 ohm here, 9 ohm here, 14 ohm here, 7 ohm here. No current is going through this. Therefore, 6 and you can change this circuit to a circuit like this. How? This will be 9 ohm and this will be 21 ohm. Right. So current is 2.5 ampere. Here the current is I1. Here the current is I2. You know I1 plus I2 is equal to. Okay, we'll take it this way. Yeah, we'll not unnecessarily introduce anything. Now we are supposed to find the current through R. So if I take that current as I, same current will be flowing through 3 ohm also, because no current is going through here. And what is the current through this one then? It will be 2.5 minus I. 2.5 minus I. Okay, so here the current is 2.5 minus I. Here the current is I, and here the current is 2.5 minus I. Now what is the plan? Across these two resistors, the potential will be equal. Now, across this resistor and this resistor, if I take the potential difference across this, I will take it as V1, if I take the potential difference across this as V2, they are equal. Why are they equal? Tell me. They are equal because they are parallel. You can say V1 is equal to V2. And for V1, you can put IR, 99. V2, you can put 21 into 2.5 pi minus I. Then 9I and 21, you can simplify by 3. So 3I equal to here 7 into 2.5 minus I. Getting 3I equal to 7 into 2.5. 7 into 2.5 is 17.5 minus 7I. So 10I is equal to 17.5. Final answer for I is going to be 1.75 ampere. Answer is first one. First one. So how many of you managed that? Good. Good, right. So the answer is that 22nd. Right. So answer is first one. So a few things we have to consider Wheatstone bridge. You have to consider this current through this as 0 and then mark one current. Don't unnecessarily introduce unknowns. If you take this as I, put this as 2.5 minus I. I don't know whether this 2.5 was visible enough for you. Without that, you can't do the question. 2.5 and then separate the current like this and do it. Right. Amanify, you had also had asked this doubt. Is it clear? Was it okay? Amani and then Rabini, Samadhi, Ishafa. Okay. Good. Right. Fine. Then there's a request for 23rd also, guys. How was it? Manageable? 23rd. Okay, we'll take 5 minutes. I'll take one quick. I'll try to finish this quickly. Wait. A car starting from rest has a constant acceleration a1 for time interval t1. During that time, it covers a distance of s1. In the next time interval t2, the car has a constant retardation a2 and comes to rest after covering a distance of s2. In time t2. In time t2. Okay. If the total distance covered by the car is s, the maximum speed attained by it will be. Okay. Right. Time can't be there in the answer. No, time can't be there. A car starting from rest has a constant acceleration of a1 for time interval t1. During that time, it covers a distance of s1. In the next time interval t2, the car has, so the graph goes like this, isn't it? The graph goes like this. This is how the graph goes. And this portion of the graph, we can take it as t1. And this portion of the graph is t2. And here the acceleration is a1. Here the deceleration is a2. Velocity time. I'm plotting a velocity time graph. And this displacement is s1. This displacement is s2. Right. The question is, what is the maximum velocity attained? This one. Let's take it as v0. Okay. Right. And total displacement is s. Now, what is the plan here? You can go to the, you can consider the velocity time graph and find the area of it. The total displacement s is equal to area of vt graph. And there, what can you do, people? Area of vt graph, s is equal to, s is there in the answer, so I'll leave it as it is. Area of vt graph is half into maximum velocity into total time, t1 plus t2. t1 plus t2, sorry, t1 plus t2. Right? Okay. And then how do you find t1 now? You can find t1 is equal half into v0. Now t1 is interesting. T1 is going to be equal to, for the first part, you can consider this equation. For the first part, if you put the equation, this equation, v equal u plus at. Okay, v is v0, u is 0, at is a1 t1. So that will give you t1 equal to v1 over a1. v0 over a1, sorry, v0 over a1. And similarly to the other part, if you apply the equation, v equal u plus at, final velocity is 0, initial velocity is v0, and for retardation minus A2 T2. So there you will be getting T2 is equal to V naught by A2. Hope you can understand. If not, velocity difference divided by acceleration will give you time. So instead of T1, you can put V naught over A1 plus instead of T2, you can put V naught over A2. I think they have taken V naught out and then it's very easy. No? S equal V naught squared by 2. Inside the bracket, we have 1 over A1 plus 1 over A2. Hope you can understand how that V naught came out. V naught is common. I take it out. There's already another V naught, becomes V naught squared. And then I think they have taken A1 and A2 LCM, and that will give you S equal V naught squared over 2 into A1 plus A2 over A1 A2. And finally, V naught squared is equal to 2S A1 A2 divided by A1 plus A2. Therefore, V naught is equal to square root of 2S A1 A2 divided by A1 plus A2. Answer first one. Yep, first one. Okay, I don't know. Someone wanted me to clarify this. I hope you understood it. Zakia. Zakia has asked for it, and someone else also had asked for it. Right, understood? And yeah, haven't drawn what you call that. If you have drawn a velocity time graph, it might have been a little tough for you. Without velocity time graph, it will be different. It will be difficult. I mean, 23, 24. Another. Anyone ask for 24? Right. Okay, 24, 24, right. 24, someone needs 25 and 25. Right. The ratio of sides AC, AB, and BC of a triangle shaped frame ABC is 4 is to 3 is to 5. And the linear expansivity of materials of the rods are alpha 1, alpha 2, and alpha 3. If this frame is heated, what should be the relationship between alpha 1, alpha 2, and alpha 3 to keep its shape same? Okay, right. Might need to do some work here. They have given a relationship there. Let's see. So to start with, you have a graph. Okay, so 4 is to 3 is to 5 means it's like a perpendicular triangle, no? Like this. Like this. So this is 3, this is 4, and this is 5. Now they're going to heat it. So, and what the problem is, the materials are different. For 4, it is alpha 1. For 3, it is alpha 2. For 5, it is alpha 3. Okay, then when you expand them, what's going to happen now? The new lengths. Now the new lengths are going to be there. So let's start with the lengths like this: 3L0, 5L0, 4L0. We'll take it that way. These are the lengths. Now the new lengths also must be the shape must be intact. That means the ratio between the new lengths should be 4 is to 3 is to 5. This is L1, this is L2, this is L3. Ratio between them should be the same. L1 to L2 to L3 must be 4 is to 3 is to 5. Right. So what's the plan here? What's the plan here, people? 5 will not. Right. Can consider Pythagoras equation. No? L1 squared plus L2 squared plus that's equal to L3 squared. Now what is L1? L1 is going to be 4L naught plus, 4L naught within bracket 1 plus alpha delta theta squared plus L2. L2 is going to be 3L naught OL naught is alpha 1, yeah. Squared. Squared is missing here. Sorry, wait. Write this. 4L naught within bracket 1 plus alpha 1 delta theta, whole thing square. Plus L2. L2 is the new length of this thing, that is 3L naught within bracket 1 plus alpha 2 delta theta, whole thing square, equal to this one. L3 square. L3 squared is 5L naught 1 plus alpha 3 delta theta, whole thing squared. Right. So here, if you look at this one, all the L naught squares will get cancelled off, and you will end up in something like this. 16 here, L naught square will get cancelled off in everything. We put 16 here, and here we have 1 plus alpha 1 delta theta square, plus here you have 9 bracket 1 plus alpha 2 delta theta square, and okay, sorry, and here you have 25 1 plus alpha 3 delta theta square. Now, when you have 1 plus alpha delta theta squared, it can actually be written as 1 plus 2 alpha delta theta. Hope you can remember this. Yeah, you can write it that way, because alpha into delta theta squared is a very small number. It's a very small number. Therefore, you can write it this way. Okay, so it is going to be what? 16 within bracket 1 plus 2 alpha 1 delta theta plus 9 within bracket 1 plus 2 alpha 2 delta theta equal 25 within bracket 1 plus 2 alpha 3 delta theta. So what will happen now, people? Okay, hope you understood that. This is important. You need to know this. And now 16 plus 9 is there, the numbers, and here we have 25. So 16 plus 9 is 25. I mean 16 plus 32 alpha 1 delta theta plus 9 plus 18 alpha 2 delta theta equal 25 plus 50 alpha 3 delta theta. So there are a lot of things are going to get cancelled off. 16 plus 9 is equal to 25. They will get cancelled off. Delta theta, it's common, gets cancelled off. So ultimately, what are we getting? What is the equation we're getting? 16 alpha 1 plus 9 alpha 2, that is equal to 25 alpha 3. Is there an answer like that? Square is there, no? Fifth should be the answer. Fifth, no, fifth ticket put they have squared, but how did they get the square? I'm wondering. Because now can't we say all alphas are equal? Can we say all alphas are equal? 40 means 4. No, man, we can't say all alphas are equal. Can we say that? 44, 33, 50. We can, no? We can. Can we? Yeah, and this becomes 4, this becomes 3, this becomes 5. But what is wrong in this method? Now, I did it step by step to explain it to you one by one, but I would have done it even faster. This one a mistake now. If the shape is going to be, what do you call that? When a potential difference is maintained across the ends of a conductor, right? Now, think of this as the conductor. And the potential difference is maintained means you connect a battery like this. Okay, when you connect a battery like that, what happens? Current flows this way. Right? Current is going to flow this way. Current is going to flow this way. But the electrons are going to get attracted to the opposite. I mean, this is minus and this is plus. So electrons are going to, going to travel in the opposite direction. No? Electrons are going to get attracted towards the positive terminal of the battery because it's like high potential. So towards high potential, it will get attracted. It's like an electric field will be created across this, where this is like the plus end, this is like the minus end. The free electrons are subjected to a set of forces acting opposite to the direction of the field. Interesting. What is the difference? Now, high potential to low potential, this is the direction of the field. And in what direction will the electron experience a force, people? Tell me. In what direction will the electron experience a force? Electron is a negative charge. Yeah. So it will be attracted towards which plate? Positive plate. I think that's what they're saying there. So the electrostatic force on the electron will be acting this way. This is the why do you have I marked the field direction of the field this way? Because plus minus, from plus to minus only we will have the electric field, right? So that should be correct. A is correct because of this reason. In other words, you have a plus plate and a minus plate. This is what you call an electric field, and this is the direction of the field, right? And if you put an electron inside this, electron means minus, it will get attracted to this, right? And then moving on, the free electron is subjected to a set of forces. Set of forces. I don't know what version. Set of forces. I didn't notice that. So one is this. The other forces. Drift velocity will be in that direction. So force. Right. Let's see. The B part, electric current flow from the point of high voltage to low voltage. That's correct. It flows from plus to minus electric current. High voltage, low voltage. Free electrons drift to the direction of electric field. That's wrong. They don't drift to the direction of electric field. They drift in the opposite direction of electric field. Electric field means plus, minus. This is, you can take this side as plus because it's connected to the plus terminal. Take this as minus. So that is wrong. C is wrong. If C is wrong, this is wrong. This is wrong. There's two statements they're asking. And definitely B is correct, isn't it? B is correct. Electricity flows, electric current flows from the, okay, this is correct. So A is wrong. It's either second or fourth. A set of forces. I can think of only one force. Any other forces acting on the electron in that direction, people? All right. So this part is a problematic part. A set of forces. They have taken 3 as the answer. That means C is correct. Maybe then this question should have been false statement. Because B is definitely correct, people. B is definitely correct. Or else, wait, electric current. Yeah, electric current means. Yeah, electric current flows from plus to minus. No, that's B is definitely correct. So I think they have taken A and B and to be correct, and maybe they want the false statement. Maybe there's a mistake in that. Right. Let's see. So what I think is first that set of force part is a bit confusing, but there's going to be only one force, electrostatic force, and when electrons travel through the positive charges in the conductor, they might experience a resistive force in the opposite direction. But apart from that, that's why they slow down. That's why the drift velocity is relatively small. That the drift velocity is not, it doesn't have the height it's supposed to have. They must be asking for the false one, guys. Maybe there's a printing error somewhere, right? They translate these papers now. between in Sinhala Nivaradi Varadi. So just one letter. In English, it's true false really clear. They are with one word, one letter actually. They might miss it. So that's it. Maybe that's where you people got stuck, anyways. Okay, then what is the next one? That's 25 for us. Then 20. There was a list of questions someone had asked. 26, 26, 27 continuously goes then. Which of the following says the force of magnetic fields is not correct. Magnetic field, lines of forces. Lines of forces means the field line. Field lines are the lines through which the force act. So this is emitted from the North Poles to reach the South Pole. Correct. The lines of forces never cross each other. Never cross each other. That's also correct. They don't cross each other. No? They are flux lines in everywhere in the field other than the neutral points. That is also okay. The point is perpendicular to the lines of forces passing the point. Direction of magnetic field. Lines of forces. Wait. The track of an imaginary North Pole having unit magnet released in the field is considered as a line of force. What? The track of an imaginary North Pole having unit magnet released in the field is considered of force. What was that? No, we don't use the term lines of forces. We normally say field lines. These people have used the lines of forces. Because when you have a current carrying wire like this, and around that there will be magnetic field lines which will be produced in this way, right? These are the magnetic field lines. What I'm drawing in red color are the magnetic field lines. And in that magnetic field, when you bring another wire, what will happen? When you bring another wire, the wire will experience a force. How? It will experience a force in the direction perpendicular. Like this, it's going to experience a force. How? Let's say it's carrying a current like this. And the direction of magnetic field will be like this, B. And it will be, the force will be in this direction. It will be experienced a force perpendicular to that. So I'm just a little confused about what they're talking about, this force thing. Force lines. The direction of magnetic field at a point is perpendicular to the lines of forces passing the point. So what do they mean by lines of forces? That's my question, people. Lines of forces, I think they by that they mean the field lines, because first two it says lines of forces never cross each other. Lines of forces emit from North Pole and reach South Pole. So by lines of forces, I think they mean the magnetic field lines. Okay, so direction of magnetic field at a point is perpendicular to the lines of forces passing the point. No, direction of magnetic field and direction of field lines are the same. We denote the magnetic field's direction by field lines. So fourth seems problematic to me. And the fifth one, what does it say? The track of an imaginary North Pole having unit magnitude released in the field is considered as a line of force. Track of an imaginary North Pole having unit magnitude released in the field. What? I'm not sure what they mean by this. I think they are talking about magnetic field lines. If they are talking about magnetic field lines, fourth should be the answer. Fifth doesn't make sense. Magnitude released in the field is considered unit magnitude. Track of an imaginary North Pole having unit magnitude as a line of force. Unit magnitude means one. Magnitude is equal to one. Unit means one. Unit magnitude released in the field considered. Okay, fine, whatever. Fourth looks like fourth to me. And by line of forces, I think they are talking about field lines. Might be a problem with this. What do you call that? Translation. We are spending a lot of time for these things. Move on to the next one. What is the next one? Sorry. Next one. Do you have problems with 27th also? Yeah, there's a request for 27th also. Let's quickly discuss this. Conducting wire is kept on a uh, vertical couple of metal aids as shown in the shown below. The mass of the wire is m and the length is l. The wire can slide on the metal aids. The couple of aids are connected by a resistor R. Right. A powerful uniform horizontal magnetic field B acts perpendicular out of the plane. The friction and resistance of conducting wire are negligible. The terminal velocity obtained under gravitational acceleration is. Okay, now this you have to know. People who haven't, how many of you know this equation? E is equal to BLV. How many of you know this equation? Okay. Right. So I'll quickly explain that to you people there. Right now here there's no magnet. All right. Sorry. Yes, there's magnet. There's no battery. There's no battery. So it's going to fall under gravity now. It's going to fall under gravity. We need to, if it is reaching a terminal velocity, that means the resultant force is zero, people. The resultant force is zero. So I'll mark the forces acting on the, what do you call that? The wire. That is mg will be acting downwards. Its weight. And there must be another force which is to balance mg. And that is the magnetic force, Fm. Then only this wire will fall under terminal velocity. Terminal velocity means a constant velocity. So to start with, our mg must be equal to Fm. Now what is Fm? Mg must be equal to Fm. Mg is mg, no change. Fm is BIL. 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 All right. So mg equal to no BIL. Terminal velocity obtained under gravitation. Oh my god, we have to find the terminal velocity. Okay. All right. Okay. Now, who is not there in the answer? I is not there in the answer. I is not there in the answer. For that, we have to do this. B is there into I. What happens is, people, when a conductor is moved in magnetic field, in that there will be a temporary EMF induced. Temporary EMF. That means it will become a battery like. It will be a battery. Now, when you move a conductor inside a magnetic field, let's say there's a magnetic field, it can be into the plane or out of the plane, doesn't matter. And you are just moving it. You are just moving it. Then it becomes a battery. And if you, while it moves, if you connect a wire to it, while it moves, that's important. It's moving. If you connect a wire to it and connect it to a bulb, the bulb will glow. The bulb will glow. Because this becomes a temporary magnet. But when it comes out of the magnet, it doesn't become a temporary magnet, it becomes a temporary battery. When it comes, bulb will go off because it's not in the field anymore. It can't be a battery. Now for that I, there are only that equation I have written here will be helpful. E is the electromotive force induced in this wire. E is the electromotive force. So there will be a battery-like thing. Now here the battery is going to be, it is falling down. So thumb down and magnetic field coming out. Yeah, current will be in this direction. So there will be a temporary battery created like this, temporary EMF in this direction. So current can go this way. This is that E means the electromotive force. Now for this circuit, when you apply sigma E equals sigma IR, sigma E is the EMF induced IR. So instead of I, you can put E over R. And what is E? That is the electromotive force induced. And how do you find E? Using this equation. Right. So instead of I will substitute that value. Which value? E over R. Into L is there in the answer. I'll write L. And mg equal B into, for E, induced electromotive force, you can substitute this. BLV over R into L. That will be equal to B squared L squared V over R. Finally, what are we supposed to find out? V. So V is equal to what? mgr divided by B squared L squared. What is the answer? Fourth one. Fourth one is the answer. Okay, so this is only for the people who have done magnetic field and people who know this equation. That comes in the latter part of magnetic field, electromagnetic induction. If you know all those things only, you can do this question. Ready? Yep. Then I hope the people understood. People who had doubt with the 27th, you got it right. What other doubts do you have, people? Did someone ask for 30th one? Wait, let me see. Okay, 29th. 29th, there's a request for 29th. What is 29th? Resistance, a wire of resistance 30 ohm, length 15 meter, and 10 ohm resistor are connected with the battery. A wire of resistance 30 ohm and a 10 ohm resistor are connected with the battery of EMF 5 volt in series. Right, so there's a battery 5 volt and there is a wire of resistance. There's a wire and a normal resistance 30 ohm, and this is 10 ohm, sorry, and the length is 15 meters. Okay, 15 meters. EMF, the internal resistance of the battery is negligible. What is the potential gradient along the wire? This is the wire. That is easy. Now this is 5 volt, 30 ohm and 10 ohm here, 30 ohm and 10 ohm, and that 5 volt will be separated across these two. How? V1 and V2, if you take it as V1 and V2, or you can take this as V and V minus R, or V1, okay, never mind, V1 over V1 and V2. You can write V1 over V, it's like this, people, current is I. So when you say V equal IR, voltage across this is V1 equal to I into resistance is 30. And here V2 is equal to same current is flowing because they are in series into 10. Therefore, V1 over V2, that is equal to 3. And at the same time, when you add V1 and V2, that is equal to 5. What are we supposed to, why I need to know V1. So V1 plus, instead of V2, I can put V1 by 3 equal to 5. 4V1 by 3 equal to 5. V1 is equal to 15 over 4. And that is 3.75 volt. That is the total voltage drop across this wire. They are asking for the potential gradient. What is the meaning of potential gradient? Potential gradient is change in potential, the potential difference divided by distance. That is how gradient is found. A difference of something must be divided by distance. So difference is 3.75 volt. And what is the distance? 15 meters. And the answer? Hopefully we have to do it. I think it's 0.25 volt per meter. I'm getting 0.25 people. Because yeah, quarter. Fourth. Okay. Shima, I hope you understood it. Shima is the one who had asked for this doubt. Right, 29th. Okay. Find the voltage, you divide by the length. That's all. That is what you call potential gradient. Basics. And anyone ask for 30th? I'm not sure. 30th. Had anyone asked for 30th? People? 30th. Yeah, 30th. Yes, okay. There were few of them had requested for 30th. So let me quickly explain that. So the supply voltage of potentiometer is 2 volt. It gives open circuit balance length 5 volt. When a 12 ohm resistor is connected parallel to the cell 1.2 volt and the balance length becomes 60 centimeter. What is the internal resistance of the cell? Okay. This is again for the people who have done potentiometer. If not, you will not understand a thing, right? So this is the potentiometer wire. So what others also can understand is, even if you haven't done potentiometer much, just see if you can relate to it. There's a wire like this. Okay, people. So if you connect it to a 2 volt cell, I think that's what they have connected, the supply voltage. That means across this wire, 2 volt will be dropped. It gives open circuit balance length of 70 centimeter for a cell of EMF 1.5 volt. So when they connect another battery to it like this, and then the battery is connected to a galvanometer, and then high resistance and all those stuff, like in meter bridge. They are saying it gives us a length of what? 70 centimeter. 70 centimeter. So remember the EMF of this battery E is equal to 1.5 volt. 1.5 volt. So the meaning is 70 centimeter represents 1.5 volt, because it's just the EMF, that's the battery was connected. So 70 centimeter represents 1.5 volt. For that, what we do is, this voltage we get here, V is equal to, we say KL. V is equal to KL, where K is called voltage drop per unit length. Voltage drop per unit length. So when you multiply voltage drop per unit length by the length, we can say 1.5 is the voltage with the battery, that is equal to K into 70 centimeters. I'll put 70, first equation. Now what they're doing is, the primary circuit, the main circuit is not changed. Let's leave it as it is. 2 volt here is not really a problem in this question. But the problem now is they are connecting the battery, and now they are allowing a current to go through the battery. That means there's another circuit like this now, the resistor. And the rest, okay. This is the galvanometer G. Galvanometer reading will be 0. That's okay. That's okay. Galvanometer reading will be 0. That's where you find the balance length. And what is the balance length now? It's given as 60 centimeter. Now there won't be any current through this part of the circuit, because that is how, when you get the balance length, when galvanometer reading is 0, that's when you get the length. In this road there's no current. But since you have put a resistor here, what will happen? Here there will be a current in this circuit. I'll take that current as I. And what is this resistor? 12 ohm. And what is the battery EMF? E is equal to 1.5 volt, and R we don't know. Now guys, what is the potential drop across this battery here? It will be 1.5 volt, because there's no current going through the battery. Even though there's an R, since there's no current going through the battery, because we know the potential drop across the battery with an internal resistance is given by V equal E minus IR. So since current is 0, current equal to 0, so you can say the potential drop across the battery is equal to E, and that's why it's 1.5. But here it's not the case. The potential drop across the battery now is going to be how much? V is equal to E minus IR. E minus IR. So here if you write the same equation, you will be getting E minus IR equal to K times, what is the length? 60. Voltage across voltage created is equal to potential drop per unit length multiplied by length. Potential drop per unit length will not change. That will be like this. This is the second equation. So let's divide the second one by first one. That will be E minus IR divided by 1.5 equal to, on the other side, 6 over 7, because it's 60 over 70, right? 6 over 7. E is something we know, 1.5, isn't it? 1.5 minus IR. I we don't know yet. Simple R also we don't know yet. And here I'll multiply 1.5 with this 6, that will give me 9. Not okay. 6 into 1.5, and here we have 7. I'll put 7 here. How do you find I, people? Now you can find current. How do you find current? The current is confined to this circuit. Current will be flowing through this circuit. Current will not go here, because when you take the balance strength, here the galvanometer reading should be 0. No? So current will be circulating within this. So for this particular circuit, if you apply Kirchhoff's law, sigma E equals sigma IR, sigma E is 1.5, current is I, and the resistance in the circuit is 12. So current is equal to 1.5 over 12. That's the current. That can be written as how much? 0.5 over 4. 5 over 40. 1 over 8. Okay, 1 over 8 ampere. That's the current. Right, then here then you have 7 into 1.5 minus 1 over 8 is the current into R equal to 6.6 into 1.5. Why didn't I multiply that? This is 7 into 1.5, here 6 into 1.5. So I can take R over 8 to this side. 7 into 1.5 minus 6 into 1.5 is just 1.5 equal to R over 8. R is equal to 8 into 1.5. Okay, now I don't have an answer like that. Where did I go wrong? I must have gone wrong somewhere in the simplification. No, I forgot to multiply the 7 people. 7, yeah, 7, 7, 7R. I mean, I forgot this. Wait, I forgot this. 7, 1.5 minus 108 into R. 108 into R equal to 6 into 1.5. So 7 into 1.5 minus 7R08 equal to 6 into 1.5. Not happy with this. Okay. And 1.5 equal 7R over 8. And R is equal to 12 over 7. Is there an answer like that? 1.7. 1. There's no answer like that. 1.5 volt, length is 70 centimeter. And when you allow a current to flow through that circuit, 12 volt is connected parallel to that. Current will flow through that circuit. So the potential drop across the battery becomes 1.5 minus E minus IR. It becomes E minus IR. For E minus IR, the corresponding length is 60. They have given. Now when you divide it, round off to 2. 2. What is the answer they have given for 30th one? Second, no? In the scheme, they have given second, is it? But okay, it's closer to 1.5 also, no? Not convinced about it. I don't know whether I made some mistake anyway. 1.5 volt, 12 ohm. Are you cut? 108. 108 is the current here. No, it is the current, and I put it here. Did I make any mistake? What do I have here? 607. 7 goes up. 1.7. 1.5. Okay, people. This is the answer. I don't know. You can't round it off to 2. You know why? 1.7 is closer to 1.5 also. On the back. So this should be the answer, but it's missing here. If not, they should have changed this length, 60 centimeter. But anyway, so if you want to know the method of how to approach a question in future, this is how you do it. All right. Here, no current is going through the battery. Therefore, all 1.5 volt will be used across the battery. 1.5 corresponds to 70. And in the other one, so 12 plus R. There. That's where I made the mistake. Good. That's where I made the mistake. Good point. Here. For resistance, thank you. For resistance, 12, and the internal resistance is also there in this circuit. So it's 12 plus R. Here you have to put 12 plus R. Right? 12 plus simple R. 12 plus simple R. Sorry, right. Then nothing. Now we will be able to. In this circuit, people, this R is an unknown. R is an unknown. That's an internal resistance. So we have to consider that in the Kirchhoff's law. Sigma E equals sigma IR. That current is flowing through 12 ohm as well as the internal resistance. Therefore, for sigma E, you will put 1.5. Current is I, we don't know. Into for resistance, you have to put 12 plus simple R as well. Because simple R is also there in that circuit. Current has to go through that internal resistance of the battery also. So I should be written as 1.5 divided by 12 plus simple R. And then now I have an equation for I to substitute. Therefore, this equation can be altered to 1.5 over 12 plus R into R. 1.5 R. 1.5 R. That is equal to 60K. Fine. Then this is the second equation. Then you have to divide you can divide the second one by first one or whatever it is. And for E, we'll substitute the value. For E, you can put 1.5. So 1.5 minus 1.5 R over 12 plus R equal to 60K. From this, you can take 1.5 out. That will be even more helpful for us later. 1 minus R over 12 plus R equal to 60K. Yeah, let's simplify one more step. you get 12 plus r as the common factor, then you have 12 plus r here minus r. You will ultimately end up in something like this: 1.5 into 12 over 12 plus r equal to 60k. And here it is 70k. Now this is the second equation. I hope you understood it. I just kept simplifying the equation and made it simple. And then let's divide the second one by first one. When you divide the second one by first one, second one, 1.5 is there, 1.5 into 12 over this is there. So 1.5, 1.5 cancels off, 12 over 12 plus r. 12 over 12 plus r. And on the other side, what do we have? 60k over 70k, that is 6 by 7. Cross multiply it. 12 into 7 is 84. 12 into 6 is 72 plus 6r. 12 is equal to 6r. R is equal to 2 ohm. Right. Answer is second. Right. Good. Amani, thank you for pointing that out. When you apply Kirchhoff's law in a circuit, remember, now the circuit is like this. When you have a circuit like this, E and internal resistance and the external resistance, and when there's a current, for this circuit, when you apply Kirchhoff's law, it should be E equals I into capital R plus simple r. So I think I forgot that simple r. To include simple r, that's where the problem starts. Okay, now I think it's clear. Yeah. Okay, people. Right. Right, fine. Then let's stop here. We have around 12 more questions to discuss. And remember, in the last paper also, we have around 12 more questions. So what I'm going to do is I will for all those within, give me like 2 to 3 days. Within those 2 to 3 days, I will send the answers for both the papers, both the remaining questions. Is in this paper, they're around 12. In the previous papers, they were around 12, right? So I'll send you the same answers. Give me like 2 to 3 days before Wednesday, right? Don't maybe even before that. I'll drop the answers to you. All right. So last 2 weeks we have done MCQs. Next week let's focus a bit more on part 2 papers, part 2 questions. Right then. Okay then. That's all for the day. Good night, everyone.